Now we are moving to section 2 of chapter 5. It's about the fundamental theorem of calculus. We will have some rules for definite integrations, and then we will move to the basic concepts of integration and how do we use them while solving examples. We have got a theorem. It says the rules are given in a theorem. Okay, it says if I have got f and g, they're both integrable. Okay, I'll write it in short. Over an interval a and b. Okay, on a and b I will simply write ab. Okay, so I have got an interval and I have got two functions which are integrable. That means I can find their integrations on the given interval. Then we have got those rules that will be given below. Okay, the first rule that we have got is the order of integration. What is order of integration? Of course, the rules that we have got here are for definite integrations. What is definite integration? Those integrations that have got limits. Okay, what were limits of an integration? That means if I have got lower limit and upper limit. Okay, so if I have got an integration that is from b to a of f of x dx, and if I want to change the order of integration, the limits of the integration, I will simply write a negative here, and the integration will be from a to b f of x dx. So if I have got the integration is from, for example, 3 to 2, and I want to change this order to 2 to 3, okay, I will simply put a negative sign here, and then I can do my integration like that. The second rule, I have got integration of a function f of x dx is equal to 0 if the bounds are the same. Okay, or it is called zero width interval. Why zero width interval? Because the interval that we have got here is from a to a. That means it doesn't have any width, it doesn't have any length. Since there is no length between the in the limit of integration, so the integration will equal to 0. For example, if you have got integration of x squared dx, you do not need to say x squared is equal to x to the power of 3 over 3, and then we input 1 and 1 into the integration, because I know that according to that rule that's simply equal to 0. Or if I have got, for example, integration from negative 5 to 5, for example, sine of x plus x minus 1 dx, you do not need to do this calculation. Why? Because the width of the integration is 0. So the result of this one, according to that rule, you will write it is directly equal to 0. The third rule that we have got is the constant multiple. So if I have got a constant multiplied to a function, I can take out that constant, okay, and simply do the integration of the function that's remained in the integral sign. So if I have got, for example, integration of 3x dx, I can change that's from a to b. I can simply take this 3 out, okay, and integration x dx will remain, okay. And of course, the integration of this one is easy to find. The fourth rule, if I have got integration from a to b of f plus g or f minus g, I will write them both together, and that is dx. That integration is linear and it will be distributed over the f and over the g with the same boundary. The boundaries do not change. Okay, that will be f dx plus or minus. That means if it is plus, I'm putting the positive sign, and if it is negative, I'm putting the negative sign, from a to b, okay, g dx. So that integral sign is distributed over those two functions. Of course, the dx is also distributed over them because we're taking the integration with respect to d. The fifth rule, I have got additivity. For example, if I have got an integration from a to b f dx plus integration from b to c f dx, That's equal to what? If you look at that integration, I have got the same function here. Okay, I have got from a to b and b to c, so that one matches with this one, the same function, and the upper limit of this one is equal to the lower limit of that function. Since it is like that, so I can write it as integration from a to c. I will skip that b, okay, from a to c of the function f dx. For example, if I have got integration from 1 to 2 of x squared dx plus integration from 2 to 5 of x squared dx. If you look at this one, if I will evaluate this one alone and evaluate this one alone, it will take some time. But since I know that the functions are the same and this boundary is equal to that boundary in here, so I will simply write from here to there, okay, 1 to 5 x squared dx. If you look at this one, evaluating this one is much more easier than evaluating this one. It is time consuming, not easier, because the integration is still the same, but it is time consuming. It will be calculated quicker. Okay, now we're moving to the domination. Okay, it has got another rule in there. The sixth one, we have got domination. If I have got f of x is greater than or equal to g of x, okay, if I have got two functions, one of them is greater than the other, then I will have definitely the integration of f of x dx is greater than or equal to integration of g of x. Okay, so if I have got two functions, one greater than the other, their integrations will definitely be greater than the other one. Now we are moving to an example. It says calculate the indefinite integrals. So I will write evaluate, okay, the followings, simply the followings. Okay, the first part that I have got, it is integration of 0 to pi of cosine x dx. If you remember, when we had definite integration, how were we calculating it? We were finding the integration and then putting pi once into the function and then 0 into the function. So let's do that integration. Here this this rule is not written there, but you are already familiar with this one. Okay, so what is the integration of cosine? If I take the derivative of which function it is equal to cosine, of course I have got sine function. Now I have taken the integration of cosine, it is equal to sine. I have to put the boundaries also from 0 to pi, because that function is working on that interval from 0 to pi. If I want to calculate this one, that will be sine of pi. You know, first I will input this one into here and then minus sine of 0. Okay, now sine of pi is equal to what? Sine pi is equal to sine of 180. Sine of 180, as you know, it is 0. Okay, minus sine of 0 is equal to 0, and the result is 0. Okay, easy. The second one, part B, I've got the integration of minus pi over 4 to 0 secant x tan x dx. Okay, the derivative of which function is equal to secant tan x? We know that the derivative of secant x is equal to secant x tan x, and I have got the interval, but here please do not write the integral sign. I have got that bar, I have to write it. So that one is from minus pi over 4 to 0. What shall we do now? We have to put 0 into the function, so secant of 0 minus secant of minus pi over 4. Okay, secant of 0, you know that secant is equal to what? Is equal to 1 over cosine. 1 over cosine of 0 is equal to 1 over 1, and that's equal to 1. I have got that minus sign here. Then I have got secant of minus pi over 4. That means cosine 1 over cosine of pi over 4, because cosine is an even function. Cosine of pi over 4 is equal to what? Is equal to 1 over root 2. 1 over 1 over root 2 is equal to root 2. Okay, you have to know these ones. We have already studied these things. So the result is equal to 1 minus root 2. We have got the third part. Integration from 1 to 4, 3 over 2 root of x minus 4 over x squared dx. In order to evaluate this integration, first I have to rearrange that integration and then taking the integral of the function that we have got. So first I will write that this integration is from 1 to 4. Look, I'm not taking the integration yet. I'm just changing the powers, okay, that root into a power. So that's x to the power of 1 over 2, okay, then minus 4x to the power of minus 2 dx. Look, I simply put this one to the numerator, make it minus, and change that square root to x to the power of 1 over 2. Now I'm taking the integration. Integration of this one is x to the power of 1 over 2 plus 1, because integration increases the power by 1. So that will be x to the power of 3 over 2 over 3 over 2. 3 over 2 underneath is cancelled with this one. So I will simply have x to the power of sorry, 3 over 2 minus I have got 4 here, and the power of this one will be negative, negative 1. So negative and negative makes it positive, and that will be 4 over x. Okay, now this is the integral form, the integrated function I mean, and the interval is from 1 to 4. How can I evaluate this one? I will simply put 4 into that function, so that will be 4 to the power of 3 over 2 plus 4 over 4. Okay, look, I once put 4 into this x and that x, and then minus from the rule, and I'm putting 1 into here, and I'm closing the bracket. Look, that's a big bracket. Okay, in the big bracket, what do I have? I am first inputting this one into that function. I will get this one. Minus is from the rule of definite integration, and then I'm putting 1 into that function, and I will get this one. It's calculated in your course material. That's equal to 8 plus 1, and that is minus 5. Okay, this one is 5, and that one is 8 plus 1. So the result is equal to 4. Okay. Now we're moving to another example. We've got total area. Or before moving to the example, I will explain area. What is area? When we are talking about integration, so far we have studied that definite integration, anti-differentiation is integration. Integration is when we are finding the integration of a function, we have got some rules that we apply to it. But what is that integration used for? We knew the applications of differentiation, the derivatives. We knew that we can find increasing, decreasing concavity, and sketching the graph of a function, and it has got so many other there are so many other applications of differentiation. But what is one of the applications of anti-differentiation, I mean integration? It is to find the area of curve, area under a curve, okay? Area of a shape that is not regular. For example, it is not square, because we know how to find the area of a square. We know how to find the area of a circle or a rectangle or a pentagon, a triangle. These ones are geometrical shapes, But how about if I have got something like this one? Uh, for example, I have got a function like that, okay? And that function from here, from that part to that part, that means from A to B, I want to find this area. How do I find this area? It doesn't look like a square, it doesn't look like a rectangle or any of the other geometrical shapes. So what shall I do? To find that area, I have to use definite integration, okay? So this is the function f of x. To find that area under that curve, okay, that shape, this part, okay? What am I going to use? I'm going to use integration. The integration I'm taking for which function? I'm finding the integration under that curve, okay? And then dx. On which interval am I taking that integration? On that interval I'm taking the integration. So that will be a to b. When I'm finding that integration, it will give me the area of that part, okay? So that one is called what? That is called the area. But I have got something. When I'm finding the area of an integration, I mean the area under a curve or a non-geometrical shape, the area is always positive. If I get a negative value, that means the graph of the function is below the x-axis. Okay, so if when I'm calculating a definite integration like this one, that means I have found the area of a function. I mean the area under a curve. Okay, area under a function, area under a curve. If I get a positive number while calculating the integration, that means the function that I have got is above the x-axis. And if I find the result of that integration a negative sign, that means that graph is below the x-axis. Instead of having it here, it will be here. Okay, so let's do example 6. So what is one of the applications of integration is to find the area under a curve. It's required from us two functions are given to us, f of x, that's equal to x squared minus 4, and another function g of x that's equal to 4 minus x squared. Okay, this one is above the x-axis, or I can say not above x-axis, it's below the x-axis, and that one is above the x-axis. It is required from us to find the definite, okay, integral over negative 2 to 2. And part B, it says find the area between the graph and the x-axis over the interval negative 2 to 2. So it has got two requirements. The first requirement, it says find the definite integration of these functions. Okay, so you're simply finding this integration. And the second one, it says find the graph of the function over that interval. And of course, when you're finding this one, you will get the same values. First, let us do the definite integration. So I have to find the definite integration of f of x dx from negative 2 to 2. That's equal to the function x squared minus 4 dx. Okay, that integration is equal to what? It is equal to x to the power of 3 over 3 minus 4x. What is the interval from negative 2 to 2? X squared is equal to this one, 4. When I'm taking the integration is equal to 4x, and the interval is equal to minus 2 to 2. Then we are putting this 2 into here and that 2 into here. I will get the result that is for yourself. Okay, do it yourself because it's not something hard. That's equal to minus 32 over 3. Okay, and then I'm finding what? That was the definite integration of the function f of x. It says find the definite integral of g of x also. So I have to find g of x dx. Okay, this one is from negative 2 to 2. That's 4 minus x squared dx. And the integration of this one is 4x minus x to the power of 3 over 3. And from minus 2 to 2. When you're calculating this one, you will get 32 over 3. So if you look at this function and that function, the results are the same but differs with the sign. Okay, why? Of course, in the first part, it is not required from you to say why this is negative 32 over 3 and why this one is 32 over 3. It's just saying find the definite integration. So the definite integration of this one is negative 32 over 3, and the definite integration of g is equal to the positive of that number. Part B, it says find the area, okay, under these curves. When we are searching for the area, so area of f of x over the interval is equal to what? From minus 2 to 2 f of x dx. So we are doing the same procedure. Again, when we get what? Is equal to negative 32 over 2. But since it's an area, can I say that an area is equal to a negative number? No, I cannot say that. So we simply put an absolute value for that integration. Okay, so what is the result of this one? That's equal to 32 over 3. Okay, we said if you have got area and we get a negative sign, what does that mean? That means the graph of the function that we have got is below the x-axis. If you look at the graph of the function of x squared, that's x squared minus 4, okay, and the interval is from negative 2 to 2. If you look at this one, it is below the x-axis. Since it's below the x-axis, we get a negative sign here. Okay, that area is equal to 32 over 3. Okay, but we put that absolute value because when we are calculating area, we should get a positive number. Now I'm searching for area of g of x. When I'm saying find the area or definite integration, it is the same meaning. What does that mean? So here, that means we are finding the area of g of x, I mean the definite integration of g of x. Look, area of g of x is equal to the definite integration. We found this one previously. What does that equal to? That's equal to 32 over 3. Why this one is a positive number? Because the g of x, the graph of g of x that we have got is above x-axis. Okay, when you're sketching the graph of 4 minus x squared, it is here. Okay, and we are finding that area. So that area is equal to what? 32 over 3. But since it is above the x-axis, it is a positive number, and we do not need to put that absolute value over there. In general, when we are finding the area of a under a curve, when you're finding the area under a curve, it may not be a function simply like that. It is maybe a function that's intersecting x-axis in many points. So in general, if we come to a summary for finding area, okay, what shall we do? What are the steps that we shall do? Of course, I have got a function f of x given over an interval. Okay, it's integrable over the interval a and b. The first thing that you have to do is to find the zeros of f of x. Okay, of f of x. What does that mean? Find zeros of that function. That means equalize that function to 0. find those numbers that make that function equal to 0. Then subdivide the interval AB at the zeros. Okay, so we are locating those zeros on the interval AB. Then we are integrating the function f over each subinterval. What we are doing here, we found the zeros. Those zeros made that interval into subintervals. For example, made it into 2 intervals, 3 intervals. Over each interval, you are integrating the function f. Okay, that is given to you. The fourth thing that we have to do, we have to add the absolute values of the integrals. Why we are adding the absolute values of the integrals? Because if you will not do those absolute values, we may get negative numbers. And negative numbers will vanish some of the parts of the area. So it is better for you to first take the absolute value so that the area becomes something positive, and then you add the results. We are given an example in here. It says find the definite integration. Let me write the example for you here. Example 7. We are given a function f of x that's equal to sine x. Okay, and that sine x is given over the interval 0 to 2 pi. It's required from you to compute, okay, compute first the definite integration, okay, and second, it's required from us to find the area of that function over the given interval. Okay, how do we sketch the graph of sine function? Let's sketch the graph of it very simply. Okay, we are not making it very nice. Here I have got the function from 0 to 2 pi. It's required from us to find the area and compute the integration of this one. Okay, that's the area. Okay, now we are finding the definite integration first. What is the definite integration? That means we are simply finding the integration of that function from 0 to 2 pi of sine of x dx, because it's required from us to only find the definite integration, so we will have no other problem. Okay, what's the integration of sine? It's equal to cosine of x minus cosine of x, and the integration is from 0 to 2 pi. What does that mean? That means first I'm putting 2 pi into the function minus cosine of 0. Okay, that minus belongs to the rule of definite integration, and that minus is considered with the cosine of x. Okay, that one is equal to what? That one is equal to minus 1. Okay, because cosine of 2 pi is equal to, positive 1. Because 2 pi comes back to the 0 place, minus cosine of 0 is equal to what? This minus and minus becomes plus. It is equal to 1. Now 1 minus 1 is equal to 0. So we computed the definite integration of sine x, and the result is 0. Now let's come to the area of that function. Okay, computation, it's okay, you get positives, negatives, 0, it is so fine. But for calculating the area of a function, between a function and the x-axis, you have to do those steps, okay, and then you're finding the definite integration. So the first step that we have got here, it says what? Find the zeros of f of x. How do you find the zeros of sine x? It is easy. We are simply equalizing sine x into 0. What are the numbers, the angles that makes sine x into 0, where x is equal to pi? Okay, when x is equal to 0, when x is equal to pi, 2 pi, 3 pi, 4 pi, but the interval that we have got here is from 0 to 2 pi. So the only number in that interval that makes sine function equal to 0 is x equal to pi. What is that? That is the 0 of sine x. That means it is the number that makes sine of x equal to 0. Now I have got the interval is from 0 to 2 pi. Where is pi? Pi is here. That is pi. So it is dividing the interval that I have got into two intervals. Look, I have got 0 to 2 pi, and pi is here. So it divided my interval into two intervals. I have to find two integrations. One of the integrations from 0 to pi I will find, okay? That is number 1. And number 2, I'm finding it from here to there, okay? So one of the integrations is this part, okay? That one is number 1, okay? And the other one is this part, from pi to 2 pi. That is number 2. The area of this part and the area of that part. Let's find the area of part 1. So I will write it here, okay? Area of part 1 is equal to sine x dx, and that's equal to minus cosine of x from pi to, from 0 to pi. Now I'm inputting pi into there. That will be cosine of pi minus cosine of 0. That's equal to what? Cosine of pi is equal to -1, okay? That's equal to -1, and that is 1. -1, -1, that's equal to -2. -2 with a negative outside, the result of this one is equal to 2, okay? That's the area of that part. So the area of that part is equal to what? Is equal to 2. Okay, it's equal to 2. Now we are going to find the area of the second part. What's the area of the second part? It's from pi to 2 pi of sine x dx. Okay. Sine x, again, the result of it, the integration of it is minus cosine of x, and that one is equal to minus cosine of 2 pi minus cosine of pi, and the result of this one is equal to -2, because this one is 1, this one is -1. 1 and -1, it's equal to 2. I have got the negative outside, so it will be -2. What is that result? It's the area of the red part, okay? It's the area of the red part. Why this one is positive, that one is negative? Because if you look at the function, here it's above x-axis and that one is below x-axis, okay? Now, we found the 0, it was pi. We subdivided the interval, okay, into two intervals, and we integrated the function that we have got over this interval and that interval. So we integrated it over each sub-interval. Now we have to add the absolute values of the integrals. So area in general is equal to what? Is equal to the result of 1, okay, in the absolute value, plus the result of number 2 in the absolute value. Or you can call this one A1, and you can call this one A2, area 1 and area 2. So that will be what? Area 1 in the absolute value plus area 2 in the absolute value. Area of 1 in the absolute value is equal to 2, and area of 2 in the absolute value is equal to 2. So that result is equal to 4. Okay? So what is the area of sine of the part that is between the sine function and the x-axis over the interval 0 to 2 pi? It's equal to 4. Look, when you're computing the function, okay, the definite integration, the result was 0. But when you are computing the area of the function, look, it's the same function and it is the same interval, but since it is the area, you have to divide the interval into subintervals. You have to find the area on each interval, and the result is different from this one. So the definite integration and the area may differ from each other, okay? And that was an example for finding the area of a function.